Hello, everyone, and welcome to another exciting version of Chip Talks podcast. Today, we're going to talk about something that's really near and dear to my heart, and that's autism. We constantly talk about autism. So, if you go back and follow this channel, you'll see lots and lots and lots of talks about autism. However, I would say my view of autism is constantly being refreshed, updated, and advanced. Autism is a very, very complicated disease, and its pathology really touches so many different systems that it's an interesting disease to study. And I kind of use it. I know so much about it that I kind of use it as my litmus test when I'm researching other things. So I'll, if I know that something's dysregulated in autism, then it's a good, way to kind of double check other ideas that I might have. So I use autism as a litmus. But what I want to talk to you guys about today really is kind of an update on where we are with, let's say, the pathology of autism, meaning kind of what's really going on, what happened, how does it work? And then I want to talk you guys through some, let's say, warning things or, things that are in our environment that might be contributing to autism and to, let's say, the prevalence of autism. So this is Autism Awareness Month. So we're going to talk a lot about autism this month, but I wanted to start off with kind of what is autism from a really deep dive perspective, but I'll try to keep that 8th grade level. And then what looks to be causal factors or what could, let's say, create, the hijack type situation that we have with autism. So we're going to talk through a couple of those things. Again, these are, just my ideas. This is I'm by no means, sit at the pinnacle of autism research, but I do follow this pretty closely. And I do pay attention. And again, there's kind of so much wrong thinking, let's say, about autism out there that I'll kind of walk you through, I guess, kind of what I think about it here. And hopefully that'll be beneficial to you guys. And again, if you're a researcher or a PhD or something out there, I'm right, first of all, but, I'm going to give you some, let's say, peer-reviewed stuff to be able to go disseminate to, judge for yourself. And I always like to do that. Again, I don't want you to take my word for it. I want you to do your own work, figure this out on your own. I'm just going to kind of give you guideposts to what to go look for. Autism can happen in a bunch of different ways, right? So we have lots of reports of kids being, let's say, born with autism. That's more unusual than kind of what happens after birth. And usually autistic symptoms will, around a year and a half, something like that, parents, if a child is autistic, let's say at that point, will begin to see symptoms. A lot of times, very interestingly, a child will develop up until 2 or 3 years old and then all of a sudden start showing signs of autism. So that just tells us it's, we don't have this figured out, right? We don't know if it's environmental. Meaning something in the environment is causing some kind of conformational change in those people, in those little kiddos, that's kind of creating this autistic situation. So we don't know if it's environmental, and that could be allergic. We don't really know if it's pathogenic. So could it be a bacteria? Could it be a bug? Could it be some kind of fungus or virus? Candida is closely associated with autism. Clostridium is closely associated with autism, which I'll talk about because that's a high possibility. But if you look at causation, so there's a lot of things, let's say, that could cause the particular hijack situation that happens with autism. So we can't really be sure yet. We can't really say, oh, it's that thing or that thing. It could be both of those things causing some common deal, that creates kind of the autism like loop, let's say. We'll talk a little bit at the end about therapies, about kind of how you can break these loops. And there's lots of different ways. If you're an autistic mama, if you have a kiddo, that has autism, if you have autism, there really is no be all end all answer yet. And don't let anybody tell you that there is. We're to the point of figuring out how this works. And once we figure out how all of it works, we'll talk about kind of ways to get in the middle, like let's say of this machine that seems to be autism. I'll talk about that a little bit at the end. Let's dive right in here. So we're gonna talk through some internet type evidence real quick. I want to kind of walk you guys down a little bit of a pathway here. We'll start here in full screen mode because I've got to use my hands. Okay. So the way your endocannabinoid system works is you use again, how do you feed it? You don't feed it with marijuana, you feed it with dietary fats. So as we eat dietary fats, we build things called endocannabinoids. And we build endocannabinoids from saturated fat, from monounsaturated fat, and from polyunsaturated fatty acids. Our main endocannabinoid comes from saturated fat, which is inflammatory, by the way, which is interesting. So in order to control inflammation, you need something that's going to inflame you. So saturated fat will create inflammation in us. It's an inflammatory fat, but it will also create an endocannabinoid mediator called anandamide, or AEA. An AEA is the main control surface on how you run your body. If your body needs to make a change, if you need to have a thought translated to action, if your nerves need to work, if your gut needs to work, any of that is going to involve the endocannabinoid system. And you need anandamide as the main control ligand. He's the main guy that's circulating in your bloodstream that will hit a CB1 receptor and do work. Okay. So he's your main control surface. Anandamide, along with his target, which is a CB1 neuroreceptor, are your engineering work surface, your control surface, how your, let's say, brain, would censor something and also make changes to something. And those somethings could be anything from nerves to brain cells to liver cells to mitochondria inside of cells. Anything that you need controlled inside of you is going to have a CB1 neuroreceptor and be affected by anandamide. Super important thing to have. And again, it all comes from saturated fat. Let's look at that in autistic people. Well, autistic people are characterized by lower anandamide. They have lower anandamide than you and I do in their blood. So they have less control surface. That's kind of obvious in let's say the symptoms of autism, isn't it? I mean, they've got less control surface, let's say, to run their neurology and run their brain system. And they've got less in their gut. They've got less. You could think of this in a lot of different ways, but they've just got less ability to control things than you and I. Now, this ability to control things is in a machine, okay? And let's call it the I never will say this word right, arachidonic acid, but the AA acid pathway, okay? And so the arachidonic acid is involved in how you rebuild anandamide. So anandamide will be broken down by something called fatty acid amyl hydrolase into arachidonic acid, and then arachidonic acid will be used to kind of rebuild anandamide. So there's this nice loop that goes on in your endocannabinoid system where you kind of keep this main control guy circulating. That loop is dysregulated in autistic people, so they have less anandamide. How would I dysregulate that loop? Okay, so now we're going to get into the discussion. Okay, so the loop is dysregulated in autistic people. They have lower anandamide, they have lower control surface, they have less ability to control their brain, they have less ability to control their neurology, they have less ability to control their impulses, they have less ability to control their feeding and craving behavior, less. Okay, so can we give them more? Maybe, as we begin to understand this loop. Okay, so pretty important discussion, right? So if I'm autistic, I want to have this discussion with you, Chip. Let's go. All right, so let's go. So let's talk about this. What is involved in this anandamide, fatty acid amyl hydrolase, arachidonic acid loop is something called COX-2, okay? Because COX-2 can take resources from this loop. In autistic people, they don't have enough anandamide. Could something be stealing or robbing their anandamide? And yes, a likely candidate is the COX-2 neuroreceptor. Now, the COX-2 neuroreceptor is also involved in the pain response, and he's responsible for making prostaglandins. Important stuff that we'll get to here in a second, so you don't necessarily have to follow along in detail, but just COX-2 is involved in sucking up endocannabinoids where you don't have them available to the rest of your body, just like in autism, okay? So he's a likely thing that's dysregulated in autism. Now, could this happen? Is it possible for this to happen? Yes, okay? And so first of all, if we're dysregulated at, let's say, in this loop, the arachidonic anandamide fatty acid amyl hydrolase loop, a way to do that is through COX-2. Okay, so COX-2 would definitely do that, and that would disrupt prostaglandins. So COX-2 is trying to make prostaglandins, and he's trying to make a bunch of prostaglandins if you have, let's say, inflammation, right? So inflammation can kind of prompt this, can start this loop. It's more than that in autism, but this is kind of what happens under inflammation. It's also what happens under a pain response, okay? Now let's kind of look at the association between this prostaglandin PGE2, which is what COX-2 is making, and this COX-2 neuroreceptor in ASD, which is autism spectrum disorder. So I'm going to read to you. I know everybody loves that when I read, but we've got people who are listening, let's say at home, without the ability to view anything. So I will read this for the listener. But regulation of PGE2 synthesis via the modulation of COX-2 activity has been implicated in the pathogenic of neurodevelopmental disease such as autism spectrum disorder. COX-2 is the main regulator of PGE2 synthesis. Abnormal COX-2 PGE signaling is associated with behavioral symptoms of autism spectrum disorder. Why? Because you don't have enough control element, because it's all getting sucked up by COX-2. Alterations in the COX-2 PGE pathway induces differential expression of ASD-related genes. Let me read that again. Alteration in the COX-2 PGE pathway induces differential expression of ASD-related genes. So the genes aren't there that cause ASD. COX-2 expression causes the genes to be expressed. Okay? Important. Hopefully you guys are getting that. Important. Irregular COX-2 PGE signaling leads to ASD-related behaviors and social abnormalities. Thus, COX-2 may be related to ASD-like behavioral symptoms in association with PGE2. You think? The associations between COX-2 and PGE2 are presented in Figure 2. And Figure 2 is a nice little pretty picture of all this that I'm reading. Of note, prostaglandin families are endogenous toxic products of COX-2 and are actively involved in the neuronal dysfunctions induced by pro-inflammatory stimuli. So this could be caused by inflammation. It's kind of what that's a quick recap. What this is saying, though, is prostaglandin synthesis, which is what COX-2 is trying to make, and COX-2 are completely messed up in autism. And wouldn't that make sense? Because that would wreck our ability to, through our endocannabinoid reclaim machine, reclaim anandamide. And this would be the very reason why anandamide is lower in autistic people. All right. So does this let's say synergy continue? Well, let's continue on. We've all heard, certainly you mamas out there have all heard about Tylenol and autism. Tylenol is a brand name, that's sold by a company. But the underlying, let's say, medicine that's in Tylenol is something called paracetamol. And so paracetamol is the underlying medicine in Tylenol. And wouldn't it be interesting if that affected this COX-2 and COX system? And it turns out, wow, it does. So it says, although paracetamol potentially reduces pain and fever, its mechanism of action, so the way it's doing things inside of you, has so far not been satisfactorily explained. It kind of has now. It inhibits both COX-1 and COX-2 weakly in vitro, but reduces prostaglandin synthesis in vivo, meaning it is going to weakly inhibit COX-1 and COX-2. Okay, so it might help with a little bit of benefit with pain and with inflammation, but it's affecting that COX-2 system. That's the important thing. And we know that COX-2 system is disrupted in autism, as evidenced by the lack of endocannabinoids, the machine, and by autism's ability to dysregulate COX-2. COX-2 is a big guy. Now, and again, paracetamol Tylenol is directly related to COX-2 actions. So are NSAIDs. Okay, so NSAIDs would also be a risk for causing, let's say, causal factors into autism, as would glycophosphate. So there's a brand called Roundup that contains something called glycophosphate. And this is a very toxic substance to bugs, but this is used, this is a weed killer, a very common weed killer that most of us put on our lawns all the time. And guess what it does? Again, if we go down here far enough, we're going to find that glyphosate will disrupt our tyrosine, tryptophan, phenylalanine pathway. He will block and disrupt this pathway. Now, the other thing that we know about autism, and I don't have it directly on here, is that it's completely the kind of tyrosine, tryptophan pathway is completely messed up in autism. So we already know that. How could that happen? Glyphosate right here. Okay, and the other thing that this does, by inhibiting this pathway, you're not making tryptophan in the proper way, and you're not making some of these intermediaries, and they're called methoxyindoles, which is, I have trouble with some of these words, they're big words, but methoxyindoles. And these guys are intermediaries that come from this, basically this pathway, this shikimate pathway, where you make tyrosine and tryptophan. So they're intermediaries that will pop out of this pathway, but they won't if you're exposed to glyphosate. And so are they important, and what do they do? Well, again, here we are right back to the old COX-2 neuroreceptor, and they affect your ability to basically control that receptor's expression. So without this 5-methoxyindole, you express a bunch of these COX-2 neuroreceptors, and you can express a bunch of these neuroreceptors. That is not a good thing if you're in an autistic situation. In fact, you want to drop back the amount of expression of COX-2 because it's something that's dysregulated. It's too much, making too much PGE2 and sucking up too many endocannabinoids. So again, the gas is stepped on COX-2. We want to kind of take our foot off the gas. A way to take our foot off the gas is this 5-MT, but this can get disrupted if we're around Roundup, glyphosate. Two important kind of things that are, again, are not direct causal agents, but can impact the dysregulation that's already associated with autism. And that's paracetamol, which is Tylenol. Those are NSAIDs because they affect the same system. And it's also things like Roundup that contain glyphosate. We're going to talk about one more thing here real quick. And again, there's a type of bacteria, and these are normally, so the Clostridia species of bacteria are common gut bacteria. So everybody has some Clostridia type bacteria in their gut. But they can get dysregulated in certain instances. And there's a certain one, Clostridia difficile, I think he's called, that can, really cause you a lot of problems. But this is something, these Clostridia dysregulations are something that are very, very common in autism. Almost every, let's say, autistic kiddo will have dysregulated Clostridia counts. Now, these Clostridia can alter a bunch of stuff in the biome. They can basically cause enough inflammatory response to set up this whole COX-2 step on the gas loop. And that's looking like exactly kind of what's happening. In fact, we might just do this here. This is always risky, but I'll bet you we can do a quick search here on Clostridia and COX-2 and look at what we find here. So we report here that toxin A induces expression. So stepping on the gas of COX-2. And, this, what I'm presenting to you guys, this is enough evidence to support writing a peer-reviewed paper to say, hey, we've likely got autism figured out. It's going to have to do with the dysregulation of COX-2 and let's say a pathology of COX-2. Now, the cool thing is, as we know this, there are things that will inhibit the expression of COX-2 that would definitely help an autistic person. We've attacked autism, you can attack autism in a bunch of different ways. So let's assume that this is the problem, this, PGE2, COX-2, lack of endocannabinoids, but the reason for it is COX-2. So how could you attack that problem? Well, you could attack that problem by de-expressing COX-2 neuroreceptors in certainly on macrophages where they appear to be really dysregulated in autism. So that would be a way to do it. you could attack this problem from the biome. So you could try to re-regulate the clostridium bacteria that are likely the guys stepping on the gas, causing the dysregulation. And you could do that with fiber in a fermenter. Okay. So fiber in a fermenter will begin to turn around a bacterial situation and kind of rewrite, let's say, a dysregulated biome. Another way that you could do this is to, and we'll kind of go back to full screen here, but another way that you could, so again, de-express COX-2, that's going to help this situation. Now, you don't want to do that everywhere because COX-2 is associated with your pain response and your inflammatory response. So you want to do that very selectively and safely. So that's a way to do it. Again, decreasing the amount of Clostridium bacteria in your gut is a way to do it. And you can do that with fiber in a fermenter. Okay. So any, apple cider vinegar and celery. Okay. So fiber in beans and apple cider vinegar. So fiber in a fermenter will begin to correct. It takes a little bit of time, but it will begin to correct an overgrowth of anything really in your biome. It will help your biome kind of correct itself. Avoid like the plague, mamas. Certainly, if you've got a child that is a newborn or a child that's under a year and a half, if you're going to vaccinate that child, absolutely avoid parsamitol. So any of the brand names, Tylenol, Motrin, and avoid NSAIDs. If your child has a fever, again, not to kind of try to sell our own products, but we have a product in True Medics called Calm that will cut a fever, very dramatically cut a fever. So there's things in nature and there's things that people offer where you can find a Tylenol-like replacement to put on your shelf. A real common thing that happens, and this, again, is this causal? There's some studies that say that it is, okay? So there's some studies that say that it isn't. And again, it's just related to this whole situation. There's lots of ways to, let's say, create this loop and cause autism, if you will, but Clostridium is the easiest way to do it. So, and that appears to be the most likely. Another way to do it, and another way to disrupt your biome and kind of leave you unprotected, and this seems to happen a lot, is mom and dad will take their kiddo in for the MMR vaccine. The MMR vaccine, mumps, measles, rubella, and that happens at about a year and a half. The MMR vaccine will cause your child to run a fever. And if your child is running a high fever, this same situation applies. So fever is the important thing, but it's caused by a vaccine in this case. And this is very common. It happens with almost every child, as your child is going to run a 104, 105 degree fever when you get that MMR vaccine, and it's going to freak you out. You're going to think your child is going to die. And they're just reacting. They have an immune response to that, vaccine. Always moms will call the doctor. Doc, my child's running 105. What do I do? Doc will say, rotate Tylenol, Motrin, Tylenol, Motrin, Tylenol, Motrin, parsamitol, 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 NSAID, NSAID. Affecting COX-2. It's also when you give a child with fever parsamitol has to be unactivated inside of you. It'll become a poison inside of you if it's not unactivated. And again, your body just naturally will unactivate it, but it will unactivate it with something called glutathione. And glutathione is what protects your liver from oxidative stress and oxidative damage. And so this is exactly what happens when you have a fever. You've got competition for glutathione. Now you take parsamitol, and that parsamitols just got free access to wreck your liver. And it hurts the liver in a place where we become dysregulated in our manufacturing of, or basically breakdown of omega-3 and omega-6 fatty acids, which is done by something called delta-6 desaturase. If you can't make or break down omega-3 and omega-6 fatty acids, you will have a whopping immune system need, and you will have to develop, let's say, the things that you need for your immune system from the biome. And this, along with Clostridium, is why autistic folks have such a disrupted biome. It's hard to kind of attack this at the biome. You can slowly go at it with fiber and a fermenter, and there's some other things to do. But anyway, the other thing about autism, I would say, is this. In your body has wind, I guess. It has, let's say, preferences. It'll have switches. and it will set preferences for certain things, based on what you eat. Okay. I call this blowing with the wind. And again, your body will also set preferences around time of day. So there's certain times of day that your body will be, let's say, energizing your liver and kind of doing things in your liver, or energizing your kidneys and doing things in your kidneys. And that's literally like clockwork. It happens like clockwork every single day. That stuff will happen. Okay. And again, if you disrupt that, you're hurting yourself. You're disrupting a natural process in your body where your body's trying to energize and repair and all that, right? So those things happen like clockwork every day. When we eat, again, we set a tone that's different than when we're not fed. So fasting and fed sets tones. And then if we're inflamed or not, depending on our environmental stimulus, all different kinds of things begin to set these tones inside of us. So if I'm set down here in a state, let's say I'm fasted, it's 3 o'clock in the afternoon, I haven't really taken any supplements, I haven't drinking much water, I'm breathing regularly, I'm not exercising. So all of those things will set a condition or a state. It's different than if I am exercising or if I'm not drinking water, or, whatever. Those states are different. Now, if I'm in this state, I may be favoring disease, and I may need to move myself out of this state to not favor disease. And this is exactly what I'm talking about with all these aspects of autism. So autistic people, have these same states, but their state is different because they have autism. So it's kind of operating at a different level. Well, if I want to change this state, let's say to a more normal type profile, again, I have to be conscious of everything that's pushing and pulling on that state. So like fasting and fed, and like time of day, and like, your immune status, and are you, tweaked from something in your environment or clostridium or not. So as we try to move those states, we have to take all these things into account. And if we sort of block and manage all of those pathways, it's really easy to get somebody to change state. We do that all the time. That's what we do, with our products in Truemetic. But it's harder with autism because there's a lot more going on. So we're getting there. That's the good news. We're getting always to a better understanding of this disease state. As we share this information with other researchers, I really hope other researchers will watch this, listen, go, wow, Chip, that's really cool. Let's talk. We need to collaborate. Those that are working on us in kind of a non-greedy, non-business-like manner, we really need to kind of solve this problem. But this problem is solvable. There's enough knowledge, let's say, out there now to solve this problem. It needs some lab work. It needs some, let's say, money, thrown at it, but it's a solvable problem. We'll leave it there for today. We will be back next week with another segment on autism. So we'll just talk about this from a little bit different aspect, but hopefully you guys have enjoyed this one, and we will see you next week for another exciting version of Chip Talks Podcast. See you guys. Bye.